Hello math lovers. In my previous video I proved the Pythagoras theorem using 14 points. That was a bit lengthy, but today I am bringing some more proofs to prove the Pythagoras theorem. There are several ways to prove the Pythagoras theorem, but today I will present you three great ways and simple ways to prove the Pythagoras theorem. So let's move to the first way. Let's go back to what did Pythagoras say. Pythagoras said that the square described on the hypotenuse is equal to the sum of the square described on the other two sides. That means a square equals to b square plus c square. We are given a right angle triangle ABC in which angle A is 90 degree. So how we are going to prove? So in the first way we are going to take 4 copies of ABC and then we will arrange them in such a way so as to form a square PQRS. And the side of this square PQRS is b plus c. So you can see that one copy of triangle ABC is here. So it is resting on B and its side C is standing. Similarly, another copy is taken. So in another copy it is resting on C and standing on B. Likewise, we can put one more triangle here and one more congruent triangle we can put here. That forms a square PQRS. So in a right angle triangle, the angles opposite of the right angles are complementary. So you can see that if in this right angle triangle, if this is 90 degree, then the sum of B plus C is also 90 degree. Now in square PQRS, we can say that PMQ is a straight line, that is 180 degree. So why it is this? Because PQ is a side of the square PQRS. So PMQ is a straight line. Then angle PMD plus angle QMN equals to 90 degree. Why it is so? Because I have already told you that in a right angle triangle, the angle which is opposite to the right angle are complementary. That means the addition of both should be 90 degree. So you can see that here angle D plus angle M should be 90 degree. Now another point is that this D is between the side C and A. Now in this triangle between C and A it is M. So this should be equal to this. This plus this is 90. So if this is equal to this, so this plus this is also 90. That is angle PMD plus angle QMN is 90 degree. So if PMQ is 180 degree and these two angles are 90 degree, then if we deduct from 180 to 90, then we'll get 90. That means this is also 90. Now we make a claim that DMNO is a square. So why DMNO is a square? DMNO is a square because all its sides are equal. They are the hypotenuse of the 4 copies of this triangle. So they have equal sides. And another point is that angle M is 90 degree. So in a quadrilateral, if there are 4 equal sides and one of the angle is 90 degree, then that is definitely a square. Now this square PQRS is equal to square DMNO plus 4 times the area of these triangles. So you can say that square PQRS is the area of square PQRS is its side square. So its side is B plus C square. Then square DMNO. So what is square DMNO? It is A square. So we can put here A square plus 4 times triangle ABC. So 4 times triangle ABC is half into base into height. So B plus C square equals to B square plus C square plus 2BC. A square comes A square. So it comes 2BC. So B square plus C square will take 2BC to the right hand side. So A square plus 2BC minus 2BC cancel. So we see that A square equals to B square plus C square. Hence the Pythagoras theorem is proved. Now I move to second way. We are given a right angle triangle, right angled at A. Now we take a copy of this triangle ABC, that means we'll take another congruent triangle and place it in such a way that ACE is a straight line and this triangle is resting on B, so this triangle should rest on C and standing on B. So we see that AB is equal to CE is equal to C and AC is equals to DE equals to B and BC equals to CD equals to A. Now we see that ABDE is a trapezium with AB parallel to DE. So how can we say that AB is parallel to ED? So because angle A is equals to angle E, that is both are 90 degree, so AB is parallel to DE and ABDE is a trapezium. Now the area of trapezium is half multiplied by AE, that is its height, multiplied by the sum of its parallel sides, that is AB plus DE. So half is half, AE is B plus C and AB is C and DE is B. So it comes out to be half bracket B plus C square. Now the area of trapezium in this case is also the sum of these three triangles, that is triangle ABC, triangle DCE and triangle BCD. So we see that triangle ABC is half B multiplied by C, triangle CDE is half multiplied by B multiplied by C, plus this triangle is half A square because both its base and height is A. So we get half 2BC plus A square. Now we can equate both the area, that is the area of trapezium and the special area of trapezium in this case. So if we equate, then half B plus C square equals to half 2BC plus A square. So now we'll simplify it. So half cancel. B plus C square equals to B square plus C square plus 2BC and A square. So we can take 2BC on our right hand side, cancel. So A square equals to B square plus C square. So hence the Pythagoras theorem is again proved with a new method. Now in the third way to prove the Pythagoras theorem, we can use the properties of similar triangles to prove our point. So in this also we are given a right angled triangle ABC, right angled at A, and we have to prove that BC square, that is this is hypotenuse, so BC square equals to AB square plus AC square. So what is the construction that we are doing in this? So in this right angle triangle from A, we are making a perpendicular to BC at D, and now triangle CAD is similar to the bigger triangle ABC. Why? Because of the angle rule, because both have a right angle. Like this bigger triangle is right angled at A, whereas this smaller triangle is right angled at D, this CDA. So both are right angle triangle and both have this angle C as common. Now sides of the similar triangles are in the same ratio, so we can take CD from the smaller triangle. So this will correspond to AC of the bigger triangle. This is equal to AC of this smaller triangle divided by BC of the bigger triangle. Then we can cross multiply CD multiplied by BC equals to AC square. This is our point 1. Now this smaller triangle ADB is also similar to this bigger triangle ABC. This is also because of the angle rule, because both are right angle triangle. So this is bigger triangle is right angled at A, whereas smaller triangle is right angled at ADB, so it is right angled at D, and both have B as a common triangle. So in the similar way we can put the ratios like DB from the smaller triangle divided by AB of the bigger triangle is equal to AB of the smaller triangle divided by BC of the bigger triangle. So we cross multiply. So BD multiplied by BC equals to AB square. Now this is our second point. So we can add the point 1 and point 2. So CD multiplied by BC plus DB multiplied by BC equals to AC square plus AB square. We take BC common from this both. So BC times CD plus DB equals to AC square plus AB square. So CD plus DB is CB or BC. So BC multiplied by BC equals to AC square plus AB square. So BC multiplied by BC is BC square equals to AB square plus AC square. So we have proved the Pythagoras theorem. So friends, today I presented you 3 very good way of proving the Pythagoras theorem. If you liked this video and if you like my way of explanation, so you can subscribe our channel and you can also share this with your friends. Let's spread the knowledge. Thank you.